Hi, hello there. Welcome to VLANs. Imagine that you are in charge of a very large conference. There are people from all over the world who share a common interest and some who also have special expertise. Imagine if each expert who wanted to present their information to a smaller audience had to do that in the same larger room with all other experts and their smaller audiences. Nobody would be able to hear anything. You would have to find separate rooms for all the experts and their smaller audiences. The virtual LAN or VLAN does something similar in a network. VLANs are created at layer 2, reducing or eliminating the broadcast traffic. VLANs are how you break up your network into smaller networks so that the devices and people within a single VLAN are communicating with each other and not having to manage traffic from other networks. The network administrator can organize VLANs by location, who is using them, the type of device, or whatever category is needed. You know you want to learn how to do this, so don't wait. Let's get started. On this video lecture, we will be talking about virtual LANs or VLANs. The module objective is that at the end of this video lecture, you should be able to implement VLANs and trunking in a switched network. So other topics included are overview of VLANs, explain the purpose of VLANs in a switched network, VLANs in a multi-switched environment. So you should be able to explain how a switch forwards frames on a VLAN configuration in a multi-switch environment. We will be also talking about the VLAN configuration. Configure a switch port to be assigned to a VLAN based on a given requirements. VLAN Trunks. Configure a trunk port on a LAN switch. And DTP or the Dynamic Trunking Protocol. Configure DTP or Dynamic Trunking Protocol in a switch. Overview of VLANs. So of course, organizing your network into smaller networks is not as simple as separating screws and putting them into jars. But it will make your network easier to manage. VLANs or virtual LANs provide segmentation and organizational flexibility in a switch network. So a group of devices within a VLAN communicate as if each device are attached to the same cable. So VLANs are based on a logical connections instead of physical connections. So as shown here in the figure, VLANs are created something like you've got VLAN 2, VLAN 3, and VLAN 4 respectively. Okay, so VLAN 2 is named IT and it was assigned an IP address of 10.0.20/24. Okay, VLAN 3 is named HR with an IP address 10.0.30/24, and VLAN 4 named Sales with IP address 10.0.40/24. Okay, now assuming that these VLANs are located on the same building, okay, it might span over 3 different floors and are connected to a single router. Okay, so VLANs in a switched network enables users in various departments, in this case IT, HR, and sales, to connect to the same network regardless of the physical switch being used or location in a campus LAN. So VLANs allow an administrator to segment networks based on factors such as function, team, or applications without regard of the physical location of users and devices. So each VLAN is considered a separate logical network. Devices within a VLAN act as if they are in their own independent network, even if they share a common infrastructure with other VLANs. So any switch or switch port can belong to a VLAN. Unicast, broadcast, and multicast packets are forwarded and flooded only on the end devices within the VLAN where the packets are sourced. So packets destined for devices that do not belong on the VLAN must be forwarded through a device that supports routing In this case, it's a router. Okay? Now, multiple IP subnets can exist on a switch network without the use of multiple VLANs. However, the devices will be in the same layer 2 broadcast domain. This means that any layer 2 broadcasts, such as an ARP request, will receive or will be received by all devices on the switch network, even by those not intended to receive the broadcast. A VLAN creates a logical broadcast domain that can span multiple physical LAN segments. So VLAN improve network performance by separating large broadcast domain into smaller ones. If a device in one VLAN sends a broadcast Ethernet frame, all devices in the VLAN can receive the frame, but devices in other VLANs do not. So using VLANs, network administrators can implement access and security policies according to specific groupings of users. Each switch port can be assigned to only one VLAN, except for a port connected to an IP phone or to another switch. Now let's talk about the benefits of VLAN design. Each VLAN in a switch network corresponds to an IP network. Therefore, VLAN design must take into consideration the implementation of the hierarchical network addressing scheme. Hierarchical network addressing scheme means that the IP network numbers are applied to a network segments or VLANs in a way that it takes the network as a whole into consideration. So blocks of contiguous network addresses are reserved for and configured on devices in a specific area of the network. So as shown here in the figure, okay, so we have here, supposedly we have VLAN 10, 20, and 30. Okay, so VLAN 10 is faculty, VLAN 20 is a student, and VLAN 30 is a guest. Okay, and they are connected to 3 different switches. So the table here below lists the benefits of designing a network with VLANs. So the first benefit would be smaller broadcast domains. So dividing a network into VLANs reduces the number of devices in the broadcast domain. So in the figure, there are 6 computers in the network, but only 3 broadcast domains. So these are faculty, VLAN 10, student, VLAN 20, and guest, VLAN 30. Next would be improved security. Okay, so only users in the same VLAN can communicate together. Now in the figure, faculty network traffic on VLAN 10 is completely separated and secured from users on other VLANs. So the next one is improved IT efficiency. VLANs simplify the network management because users with similar network requirements can be configured on the same VLAN. So VLANs is named or can be named to make them easier to identify, like what we did in the figure. So VLAN 10 was named faculty, VLAN 20 was named student, and VLAN 30 was named guest. So the next benefit would be reduced cost. So VLANs reduce the need for expensive network upgrades and use the existing bandwidth and uplinks more efficiently, resulting in a cost savings. Better performance. The smaller broadcast domains reduce unnecessary traffic on the network and improve performance. And simpler management or simpler project and application management. So VLANs aggregate users and network devices to support business or geographic requirements. So having separate functions makes managing a project or working with a specialized application easier. An application or an example of such an application is an e-learning development platform for faculty. Let's talk about the types of VLANs. So there are several types of VLANs. VLANs are used for different reasons in modern networks. Some VLAN types are defined by traffic classes. other types of VLANs are defined by the specific function they serve. Okay? And we named it as default VLAN. Okay? The default VLAN on a Cisco switch is VLAN 1. Therefore, all switch ports are on VLAN 1 unless it is explicitly configured to be on another VLAN. So by default, all layer 2 control traffic is associated with VLAN 1. Okay, so if you will observe here, given a switch, we typed in the command show VLAN brief. If you will observe, all the switch port on this switch belongs to the default VLAN, which is VLAN 1. Okay, now what are the important facts to remember about VLAN 1? So that includes the following. First, all ports are assigned to VLAN 1 by default, as shown here. The native VLAN is VLAN 1 by default also. The management VLAN is VLAN 1 also by default. And VLAN 1 cannot be renamed or deleted. For instance, again in the figure, with the show VLAN brief here, all ports are currently assigned to a default VLAN 1. No native VLAN is explicitly assigned and no other VLANs are active. So therefore, the network is designed with a native VLAN the same as the management VLAN. This is considered a security risk. So the next type of VLAN is data VLAN. Data VLANs are VLANs configured to separate user-generated traffic. They are also referred to as the user VLANs because they separate the network into groups of users or devices. So a modern network would have many data VLANs depending on organizational requirements. Note that voice and network management traffic should not be permitted on data VLANs. So the next type of VLAN is native VLAN. So user traffic from a VLAN must be tagged with its VLAN ID when it is sent to another switch. Trunk ports are used between switches to support the transmission of a tagged traffic. Specifically, an 802.1q trunk port inserts a 4 bytes, or 4-byte tag in the Ethernet frame header to identify the VLAN to which the frame belongs. A switch may also have to send untagged traffic across the trunk link. Untagged traffic is generated by a switch and may also come from legacy devices. So the 802.1q trunk port places untagged traffic on the native VLAN. The native VLAN on a Cisco switch is VLAN 1, remember? Default VLAN. So it is a best practice to configure the native VLAN as an unused VLAN, distinct from VLAN 1 and other VLANs. So in fact, it is not unusual to dedicate a fixed VLAN to serve the role of the native VLAN for all trunk ports in a switch domains. So the next one would be a management VLAN. Okay, so the management VLAN is a data VLAN configured specifically for network management traffic, including SSH, Telnet, HTTPS, HTTP, and SNMP. So by default, VLAN 1 is configured as the management VLAN on a layer 2 switch. But on the course, okay, so we usually use VLAN 99 to be our management VLAN. Okay, so the next type of VLAN is a voice VLAN. A voice VLAN is a separate VLAN, okay, needed to support voice over IP or VoIP. So VoIP traffic requires the following, okay, assured bandwidth to ensure voice quality. Okay, so transmission priority over the other types of network traffic, we call it the quality of service priority. Okay, you also have the ability to be routed around congested areas on the network. Delay of less than 150 milliseconds across the network. Now, to meet these requirements, the entire network has to be designed to support VoIP. So in the figure here, VLAN 150 is designed to carry voice traffic. Okay. Now the student computer, PC5, this is attached to a Cisco IP phone. And the phone is attached to switch 3. So PC5 is in VLAN 20, which is used for student data. VLANs in a multi-switch environment. Let's start with defining VLAN trunks. So VLANs would not be very useful without VLAN trunks. VLAN trunks allows all VLAN traffic to propagate between switches. This enables devices connected to different switches but in the same VLAN to communicate without going through a router. So a trunk is a point-to-point link between two network devices that carries more than one VLAN. So a VLAN trunk extends VLAN across the entire network. Now Cisco switches supports 802.1q for coordinating trunks on a fast Ethernet, Giga Ethernet, and 10 Gigabit Ethernet interfaces. So a VLAN trunk does not belong to a specific VLAN. Instead, it is a conduit for multiple VLANs between switches and routers. So a trunk could also be used between a network device and a server, or another device that is equipped with an appropriate 802.1q capable NIC or network interface card. So by default, on a Cisco Catalyst switch, all VLANs are supported on a trunk port. Now in the figure here, the highlighted links between switch 1 and switch 2, okay, so this one here, okay, FA01 and FA01, okay, and between switch 1 and switch 3, in that case that is FA03 and FA03 on switch 3 respectively, these are configured to transmit traffic coming from VLAN 10, 20, and 30. And of course, if we have VLAN 99 here, okay, example, native VLAN or the management VLAN across the network. So this network could not function without VLAN trunks. Okay, so this is what you call trunk here. Okay, so the connection between switches are what you call trunks. All right. How about networks without VLANs? So what will happen, or what is the behavior of a network if it don't have a VLAN configured on it? So when a switch receives a broadcast frame on one of its ports, it forwards the frame out all other ports except the port where the broadcast was received. So in the animation here, the entire network is configured in the same subnet. And these are at 172.40.0/24. So since this is a /24 here, the network address used here would be 172, okay, .17.40, okay, .0/24. So that means these 3 switches here and 6 workstations belongs to the same network or same subnet, which is at 172.17.40.0/24, and no VLANs are configured. So as a result, when the faculty computer, which is PC1 here, being our source, sends out a broadcast frame with switch 2, what actually happens is that it forwarded the traffic or the frame to all the interfaces on switch 2, except of course on FA011, where the packet or where the frame came from. Okay, so eventually the entire network receives the broadcast because the network is one broadcast domain. So even though we have 3 switches here, it is considered to be a one broadcast domain because all of these workstations or computers are on the same subnet, and without any VLAN configured on it, all of it are said to be on VLAN 1. Okay, so what will happen if we have configured a VLAN on the switch? Okay, so in here, faculty devices are assigned to VLAN 10. Okay, so you've got VLAN 10 here for faculty. Okay, also PC1 is in faculty and PC4 is also on faculty or VLAN 10. Okay, and the student were assigned on VLAN 20. PC2 and PC5 are part of the student VLAN. Okay, now when a broadcast frame is sent from faculty computer, okay, or from PC1, it will be forwarded only to a computer within that VLAN. Okay, so if you will observe on this animation, when a broadcast frame is sent from a faculty computer PC1 to switch 2, the switch forwards the broadcast frame only to those switch ports configured to support VLAN 10. And in that case, that's between PC4 and PC1 only. So the traffic will not be forwarded by the switch on the other VLAN, in this case, VLAN 20, which are PC2 and PC5 student VLAN. Okay? Now, the ports that comprise the connection between switch 2 and switch 1 ports, which is FA01, and between switch 1 and switch 3 here, in that case, these two links here, this would be our trunk, which supports both VLAN, VLAN 10, and VLAN 20. So take note that trunks should support all the VLANs configured on the network. Okay? Now, when switch 1 receives the broadcast frame on FA01, okay, so switch 1 forwards that broadcast frame out of the only other port configured to support VLAN 10, which is FA03. Okay, now when switch 3 receives the broadcast frame on FA03, it forwards the broadcast frame out the only other port configured to support VLAN 10, which is port FA011. Okay, so this would be our destination there. Now, the broadcast frame arrives at the only other computer in the network configured in VLAN 10, which is faculty computer PC4. Okay, now when VLANs are implemented on a switch, the transmission of unicast, multicast, and broadcast traffic from a host in a particular VLAN are restricted to the devices that are in that VLAN. All right. Okay, so next would be the VLAN identification with a tag. So the standard Ethernet frame header does not contain information about the VLAN to which the frame belongs. So therefore, when the Ethernet frames are placed on a trunk, information about the VLANs to which they belong must be added. Okay, now this process is called tagging. So it is accomplished by using the IEEE 802.1q header specified in the IEEE 802.1q standard. The 802.1q header includes a 4-byte tag inserted with the original Ethernet frame header, specifying the VLAN to which the frame belongs. So when the switch receives a frame on a port configured in an access mode and assigned a VLAN, the switch inserts a VLAN tag in the frame header, recalculates the frame check sequence or FCS, and sends the tag frame out a trunk port. Okay, now the VLAN tag field details. So as shown here on this diagram, okay, so let me just change to pointer. Okay. All right, so as shown here in the figure, the VLAN tag control information field consists of a type field, a priority field, okay, a canonical format identifier, or the CFI, and a VLAN ID field. Okay, now let's go with each of the field there. So let's start with the type. Now, type is a 2-byte value called the tag protocol ID or TPID. Okay, so for Ethernet, it is set to hexadecimal 0 by 8100. Okay, so the next one is the user priority or PRI. Okay, so this is a 3-bit value that supports level or service implementation. Okay, so the next field would be the canonical format identifier or the CFI. So CFI is a 1-bit identifier that enables token ring frames to be carried across the Ethernet links. And the last one here is the VID or the VLAN ID. So this is a 12-bit VLAN identification number that supports up to 4096 VLAN or VLAN IDs. Okay. Now, after the switch inserts the tag control information fields, it recalculates the frame check sequence or FCS values and inserts the new FCS into the frame. All right. Native VLANs and the 802.1q tagging. So the IEEE 802.1q standard specifies a native VLAN for trunk links, which defaults to VLAN 1 as we discussed earlier. Okay. Now, when an untagged traffic or untagged frame arrives on the trunk port, it is assigned to the native VLAN. So management frames that are sent between switches is an example of traffic that is typically untagged. Now, if the link between two switches is a trunk, the switch sends the untagged traffic on the native VLAN. All right. So tagged frames on the native VLAN. So some devices that support trunking add a VLAN tag to native VLAN traffic. So control traffic sent on the native VLAN should not be tagged. If an 802.1q trunk port receives a frame or a tagged frame with a VLAN ID that is the same as the native VLAN, it drops the frame. Consequently, when configuring a switch port on a Cisco switch, configure devices so that they do not send tagged frames to the native VLAN. So devices from other vendors that support tagged frames on the native VLAN, including IP phones, servers, routers, and non-Cisco switches. Okay? Now, let's talk about the untagged frames on the native VLAN. When a Cisco switch trunk port receives untagged frames, which are unusual in a well-designed network, it forwards those frames to the native VLAN. If there are no devices associated with the native VLAN, which is not unusual, and there are no other trunk ports, which is not unusual also, then the frame is dropped. The default native VLAN, okay, is VLAN 1 on a Cisco switch. Okay. Now, when configuring an 802.1q trunk port, a default port VLAN ID or PVID is assigned to the value of the native VLAN ID. All untagged traffic coming in and out of the 802.1q port is forwarded based on the PVID value. For example, if VLAN 99 is configured as the native VLAN, the PVID is 99, and all untagged traffic is forwarded to VLAN 99. Okay? If the native VLAN has not been reconfigured, the PVID value is set to VLAN 1. Now, in the figure here, so PC1 is connected by a hub. Okay, so this is a hub here to an 802.1q trunk link. So PC1 sends untagged traffic, which the switches associated with the native VLAN, okay, configured on the trunk ports and then forward accordingly. Now, tagged traffic on the trunk received by PC1 is dropped. This scenario reflects poor network design for several reasons. First, it uses a hub. It has a host connected to a trunk link, and it implies that the switches have access ports assigned to the native VLAN. It also illustrates the motivation for the 802.1q specification for native VLANs as a means of handling legacy scenarios. So nowadays, basically, we don't use a hub on a network. Okay, so mostly implementations are done via or through switches. Voice VLAN tagging. A separate voice VLAN is required to support VoIP or the voice over IP. This enables quality of service or QoS and security policies to be applied to voice traffic. So a Cisco IP phone connects directly to a switch port. As you can see here, we've got an IP phone that is directly connected to switch 3. Okay? Now, an IP host can connect to the IP phone to gain network connectivity as well. As you can see here, PC5 is connected to the IP phone. So the access port connected to the Cisco IP phone can be configured to use two separate VLANs. One VLAN is for voice traffic, and the other VLAN is a data VLAN to support the host traffic. So the link between the switch and the IP phone simulates a trunk link to carry both voice and data VLAN traffic. So specifically, the Cisco IP phone contains an integrated 3-port 10 or 100 switch. Okay, so the ports provide dedicated connections to the following devices. So port 1 here. Okay, you've got port 1. This connects to the switch or other VoIP device. Now port 2 is an internal 10-100 interface that carries the IP phone traffic. And port 3, this is an access port which connects to a PC or other devices. Okay, now the switch access port sends CDP or Cisco Discovery Protocol packets instructing the attached IP phone to send voice traffic in one way or in one of the 3 ways. The method used varies based on the type of traffic. Okay, now if it is a voice VLAN traffic, it must be tagged with an appropriate layer 2 class of service or COS priority value. If it is an access VLAN traffic, it can also be tagged with a layer 2 COS priority value. If it is an access VLAN, okay, is not tagged, no layer 2 COS priority value. Now in the figure, the student computer, which is PC5 here, is attached to a Cisco IP phone. And the phone is attached to switch 3 or S3 here. Now VLAN 150 is designed to carry voice traffic, while PC5 is in VLAN 20. Okay, so which is used for student data. Voice VLAN verification example. So the example output on the show IP interface FA018 here, okay, the highlighted areas in the sample output of the FA018 interface configured with a VLAN that is configured for data VLAN 20. Okay, and a VLAN configured for voice, which is VLAN 150. VLAN configuration. So creating a VLAN, like most other aspects of networking, is a matter of entering the appropriate commands. So this topic details how to configure and verify different types of VLANs. Okay, so different Cisco Catalyst switches support various numbers of VLANs. The number of supported VLANs is large enough to accommodate the needs of most organizations. For example, the Catalyst 2960 and 3560 supports over 4,000 VLANs. That's a lot of VLANs. So normal range VLANs of the switches are numbered 1 to 1005. Okay? And extended range VLANs are numbered 1006 to 4094. The figure illustrates the numbered 1006 or 1006 to 4094. Okay, so the figure illustrates the default VLANs on the Catalyst 2960 running Cisco iOS release 15.x. Okay, so you also have the normal range VLANs. So the following are the characteristics of the normal range VLANs. So they are used in a small and medium-sized business and enterprise networks. They are identified by a VLAN ID between 1 to 1005. Okay, IDs 1002 to 1005 are reserved for legacy network technologies like token ring and the FDDI or the fiber distributed data interface. Now IDs 1, okay, 1002 to 1005, including 1003, 1004, and 1005, are automatically created and cannot be removed or deleted. So configurations are stored in a switch flash memory in a VLAN database file called VLAN point dot. All right. Now, when configured, VLAN Trunking Protocol or VTP helps synchronize the VLAN database between switches. So the next one would be the extended range VLAN, which is from 1006 to 4095. Okay. Now, the following are the characteristics of an extended range VLANs. They are used by service providers to service multiple customers and by global enterprises large enough to need extended range VLANs. They are identified by a valid ID between 1006, okay, and 4094 or 4094. So configurations are saved by default in the running configuration. Okay. Now, they support fewer VLANs features than the normal range VLANs. So requires VTP transparent mode configuration to support extended range VLANs. So take note that 4096 or 4096 is the upper boundary for the number of VLANs available on a catalyst switches, because there are about 12 bits in the VLAN ID field of the IEEE 802.1q header. Next would be VLAN creation command. So how do we create a VLAN? How do we configure a VLAN? So when configuring a normal range VLANs, the configuration details are stored in a flash memory on a switch in a file called VLAN point dot, as mentioned earlier. Flash memory is persistent and does not require the copy running config startup config command or copy run. However, because other details are often configured on a Cisco switch at the same time that VLANs are created, it is a good practice to save configuration, okay, or save the running config changes to the startup config. Now, the table here displays the Cisco iOS command syntax used to add VLAN on a switch and give it a name. So naming each VLAN is considered a best practice in a switch configuration. So how do we do it? So of course, you need to start with configure terminal, just like in a router, conf t, and then VLAN, the VLAN number. Okay, so you can use any VLAN number other than 1 and other reserved numbers. Okay, and then you give it a name, something like VLAN, let's say you've got VLAN 10, name faculty. Okay, and then end, that's it. All right. Okay, so let's have an example here. In the topology, the student computer PC2 has not been associated with a VLAN yet, but it does not have an IP address. Okay, so that's why we're going to assign an IP address here. Okay, so let's use, for instance, 172.17.20.22, which belongs to VLAN 20. So VLAN 20 here uses the block of IP address 172.17.20.0, maybe it's /24. Okay, so take note that in addition to entering a single VLAN ID, a series of VLAN IDs can be entered, separated by commas, or a range of VLAN IDs separated by hyphens using the VLAN ID command. Okay, so for example, entering a VLAN, something like 100, 102, 105 to 107 or 105-107 global configuration command would create VLANs 100, 102, 105, 106, and 107. So hyphen is used to define the range of VLANs. Okay, so to create VLAN 20, for instance, we'll have here VLAN 20 name student and simple as that. So we have successfully created VLAN 20 and we have successfully named it student. That's how easy it is to create a VLAN. Okay, so after creating a VLAN, the next step is to assign ports to that VLAN. So this table here displays the syntax for defining a port to be an access port and assigning it to a VLAN. Access port meaning we are going to connect a switch to that port or a PC to that port, sorry. Okay, so again, access port means we are going to connect a workstation or a PC on that switch port. If we are going to connect another switch on that switch port, we configured it as trunk. So the switch port mode access is optional, but strongly recommended as a security best practice. With this command, the interface changes the permanent to permanent access mode. Okay, so take note that the interface range command, as I have mentioned earlier, to simultaneously configure multiple interfaces can be used. Okay, so again, to assign a port to a VLAN or a switch port to a VLAN, we use the syntax here. So configure terminal, interface, the interface ID, switch port mode access, switch port access, VLAN number. Okay, so let's have an example on that. Now again, going back to this figure here, okay, so FA06 on switch 1 is configured as an access port and assigned to VLAN 20. So in this case, this is FA018. Okay, so FA018 will be configured to be part of VLAN 20. So any device connected to that port will be associated with VLAN 20. Therefore, in our example, PC2 here is in VLAN 20. Okay, so how do we configure it? So configure terminal, interface FA018. So bear with me. This is FA018 here. Okay, so let me just correct it. So maybe we are just going to change this to FA06. Okay, so interface FA06, switch port mode access, switch port access VLAN 20. And so that means we have successfully joined FA06 to be part of VLAN 20. So this is now VLAN 20 here. All right. So next is data and voice VLANs. Okay, an access port can belong to only one data VLAN at a time. However, a port can also be associated to a voice VLAN. So for example, okay, so again, let me bring it back to the laser pointer. A port connected to an IP phone and an end device would associate it with two VLANs, one for voice and one for data. Now consider the topology in the figure here. So PC5 is connected to the Cisco IP phone, okay, so which in turn is connected to Fast Ethernet 018. Okay, so that is on switch 3. Now to implement this configuration, a data VLAN and a voice VLAN are created. Okay. Now we use the switch port voice VLAN ID configuration command to assign a voice VLAN to a port. So LAN supporting voice traffic typically also have quality of service enabled. So voice traffic must be labeled as trusted as soon as it enters the network. So we use the command MLS QoS trust, okay, COS, okay. So this configuration command to set the trusted state of an interface and to indicate which fields of the packet are used to classify traffic. So the configuration in the example creates two VLANs. Okay, so starting with VLAN 20 named student and VLAN 150 named voice. So we have created here two different VLANs. Okay, and then the next one is we are going to assign voice traffic to VLAN 150 and enable QoS classification on that VLAN. So that would be FA018, switch port mode access, switch port access VLAN 20. This is for the workstation. Okay, that belongs to VLAN 20. And for VLAN 150, you've got switch port voice VLAN 150. Okay, so don't forget MLS QoS trust COS command. So it also assigns voice traffic to VLAN 150 and enables QoS classification based on the class of service or COS assigned by the IP phone. Now, take note that the implementation of QoS is beyond the scope of this course, right? So you'll be encountering QoS when you reach the final module of the CCNA. Now, the switch port access VLAN command forces the creation of a VLAN if it does not already exist on the switch. For example, VLAN 30 is not present in the show VLAN brief output of the switch. Now, if switch port VLAN or access VLAN 30 command is entered on any interface with no previous configuration, the switch displays the following. Okay, so which is access VLAN does not exist, creating VLAN. So if you are going to assign a switch port to a non-existing VLAN, so basically this is what you have. The switch will automatically create that VLAN for your assignment, but it doesn't assign a name. All right, so it will be assigned to a VLAN number, but you don't have a name. So you have to manually name that VLAN afterwards. So next would be, how do we verify VLAN information? So after a VLAN is configured, VLAN configuration can be validated using Cisco show commands. The show VLAN command displays a list of all configured VLANs. The show VLAN command can also be used with options. So the complete syntax of a show VLAN, okay, would include something like show VLAN brief, ID, VLAN ID, the name, okay, VLAN name, and then summary. Now the table describes the show VLAN command options. All right, so this would include display of VLAN name, status, and each ports, one per line with brief command. Or if you use the VLAN ID, okay, display information about the identified VLAN ID number. So next would be the name, VLAN name, display information about the identified VLAN name. The VLAN name is an ASCII string from 1 to 32 characters. And summary is display VLAN summary information. So other useful commands that are the show IP interface brief, interface ID, switch port, and the show interface VLAN, VLAN ID command. Okay, so for example, the show interface FA018 switch port command can be used to confirm that the fast Ethernet 018 has been correctly assigned to data and voice VLAN. Okay, so shown here. So you've got show interface VLAN 20. All right. Okay, so changing the VLAN port membership. There are a number of ways to change a VLAN port membership. If the switch access port has been incorrectly assigned to a VLAN, then simply re-enter the switch port access VLAN ID interface configuration command with the correct VLAN ID. Okay, so for instance, assume FA018 was incorrectly configured to be on the default VLAN 1 instead of VLAN 20. Okay, so to change the port to VLAN 20, we simply enter switch port access VLAN 20. Okay, to change the membership of a port back to a default VLAN, we use the command no switch port access VLAN. Okay, so as shown here, for instance, interface FA018 no switch port access VLAN. This will change the membership of a port back to a default VLAN 1. Okay, also in the output, okay, FA018 is configured to be on the default VLAN as confirmed by the show IP or show VLAN brief command here. Okay, show VLAN brief, it confirms that FA018 is now a member of VLAN 1. So after we switch it back to on default VLAN. Okay, now the show interfaces 018 switch port output can also be used to verify that the VLAN for interface FA018 has been reset to VLAN 1, okay, as shown here. So if you will observe here, after we execute the show interfaces FA018 switch port, the access mode now is VLAN 1 or default. Okay? Deleting VLANs. So the no VLAN ID global configuration mode command is used to remove a VLAN from the switch VLAN point.dat file. Okay? So caution, before deleting a VLAN, you need to reassign all member ports to a different VLAN first. So any ports that are not moved to an active VLAN are unable to communicate with other hosts after the VLAN is deleted and until they are assigned to an active VLAN. Okay? So the entire VLAN point.dat, okay, the entire VLAN point.dat can be deleted using the command delete flash VLAN point.dat, okay, on the privilege exec mode command, or simply delete VLAN point.dat command. Okay? Now, the abbreviated command version, which is this one, delete VLAN point.dat, can be used if the VLAN point.dat has not been moved from its default location. So after issuing this command and reloading the switch, any previously configured VLANs are no longer present. So this effectively places the switch into its factory default with regard to VLAN configuration. Okay? Now, to restore a catalyst switch to its factory default condition, unplug all the cables except the console and power cables from the switch. Then enter erase startup config on the privilege exec mode command, followed by delete VLAN point.dat command. Okay, and that's it. You have successfully deleted and restored to factory default. VLAN Trunks. Now that you have configured and verified VLANs, it is time to configure and verify VLAN Trunks. So a VLAN Trunk is a layer 2 link between two switches that carries traffic for all VLANs, unless the allowed VLAN list is restricted manually or dynamically. So to configure trunk links, okay, so we are using the command switch port mode trunk on the interface. Okay, so this will summarize how to configure a trunk on the switch. So configure terminal, go to the specific switch port number, so interface ID, switch port mode, trunk. Again, the other mode we used earlier would be access. Access is for the computers or workstations, whereas trunk if we are going to connect a switch to that switch port. So switch port trunk native VLAN, we've talked about native VLAN earlier, which is set to default VLAN 1. And then switch port trunk allowed VLAN lists. That is if you want to specify the VLAN ID that will be allowed on the trunk. So by default, all VLANs will be allowed to use the trunk. But if you have manually set, okay, so which VLAN will be allowed, then we use the command switch port trunk allowed VLAN 10, 20, and so on. All right. So in the figure here on our example, so VLANs 10, 20, and 30 supports the faculty, student, and guest computers, PC1, PC2, and PC3. So FA01 on switch 1 and switch 2 will be configured as trunk port, and forward traffic for VLANs 10, 20, and 30. So VLAN 99 is configured as the native VLAN on this example. Okay, so the example shows the configuration of port FA01 on switch 1 as trunk port. The native VLAN is changed to VLAN 99, and the allowed VLAN list is restricted to 10, 20, 30, and 99. Okay, so how's the configuration? So on switch 1, okay, you go to the interface FA01 there, So interface fast Ethernet 01. So switch port mode trunk. Switch port trunk native VLAN 99. Okay. And then switch port trunk allowed VLAN 10, 20, 30, and 99. Now, if you have created other VLANs aside from this specified here, for instance, you have created VLAN 40, it will not be allowed to use the trunk unless you include it on the list. Okay? Now, this configuration assumes the use of the Cisco 2960 or the Catalyst 2960 switches, which automatically uses the 802.1q encapsulation on trunk links. So other switches may require manual configuration of the encapsulation. Okay, so always configure both ends of the trunk with the same native VLAN. So if we have configured here native VLAN 99, then on switch 2, you also need to use VLAN 99 as the native VLAN. Okay, now if 802.1q trunk configuration is not the same on both ends, so the Cisco iOS software reports an error. Right, so you're gonna have a notification on your screen. So how do we verify trunk configuration? So the switch output displays the configuration of a switch port FA01 on switch 1. Okay, so after you have executed something like switch port mode trunk, no switch port trunk, native VLAN 99. Okay, so switch port is enabled, administrative mode is trunk, operational mode is trunk, administrative trunk encapsulation by default that uses the 802.1q. Okay, and then trunking native mode VLAN 99, you've got so VLAN 99 there. Okay, now the top highlighted area shows that FA01 has its administrative mode set to trunk as mentioned earlier. So that means the port is in trunking mode. Okay. Now the next highlighted area verifies that native VLAN 99 or the native VLAN is VLAN 99. So further down, okay, so the bottom highlighted area shows that VLANs 10, okay, to VLAN 10, 20, 30, and 99 are enabled on the trunk. Okay, so that's it. Now, how do we reset trunk to the default state? So we simply use the no switch port trunk allowed VLAN and no switch port trunk native VLAN commands to remove the allowed VLANs and reset the native VLANs on the trunk. So when it is reset to the default state, the trunk allows all VLANs and uses VLAN 1 as the native VLAN. So the example shows the command used to reset all trunking characteristics of a trunking interface to the default setting. Okay, so example in here, interface FA01, no switch port trunk allowed VLAN, and then no switch port trunk native VLAN. Okay, the show interfaces FA01 switch port command reveals that the trunk has been reconfigured to a default state. So if you will see here, access mode VLAN 1 default. Okay, trunking VLANs enabled all. Okay, so that means it is already on the default state. Okay, now this sample output shows the command used to remove the trunk feature from the FA01. Okay, on switch 1. Okay, so the show interfaces FA01 switch port command reveals that FA01 is now in static access mode. All right. On this section, we will be talking about Dynamic Trunking Protocol or DTP. So let's have an introduction first about the Dynamic Trunking Protocol or DTP. So some Cisco switches have a proprietary protocol that lets them actually negotiate trunking with a neighboring device. This protocol is called the Dynamic Trunking Protocol or DTP. So DTP can speed up the configuration process for a network administrator. Ethernet trunk interfaces supports different trunking modes. An interface can be set to trunking or non-trunking, or to negotiate trunking with the neighbor interface. So trunk negotiation is managed by DTP, which operates on a point-to-point basis only. So that is between network devices. So DTP is a Cisco proprietary protocol that is manually enabled on a Catalyst 2960 and Catalyst 3560 series switches. So DTP manages trunk negotiation only if the port on the neighboring switch is configured in a trunk mode that supports DTP. So switches from other vendors do not support DTP. All right. So you have to take note that some internetworking devices might forward DTP frames improperly, which can cause misconfiguration. So to avoid this, turn off DTP on Cisco switch interfaces that are connected to devices that do not support DTP. All right. So the default DTP configuration for the Cisco Catalyst 2960 and 3560 switches is Dynamic Auto. So to enable trunking from Cisco switch to a device that does not support DTP, we use the command switch port mode trunk, okay, and switch port non-negotiate interface configuration mode command. This causes the interface to become a trunk, but it will not generate DTP frames as shown here. Okay, so switch port mode trunk, switch port non-negotiate. So to re-enable dynamic trunking protocol, use the switch port mode dynamic auto command. So that is switch port mode dynamic auto. So if the ports connecting to switches are configured to ignore all DTP advertisements, with the switch port mode trunk and the switch port non-negotiate, okay, the ports will stay in trunk mode. So if connecting ports are set to dynamic auto, they will not negotiate a trunk and will stay in the access mode state, creating an inactive trunk link. So when configuring a port to be in a trunk mode, we use the switch port mode trunk command. Then there is no ambiguity about which state the trunk is in. It is always on. Okay? Now, the switch port command has additional options for negotiating the interface mode. So the full syntax or command syntax is the following. Okay? So you're gonna have switch port mode, access, dynamic auto, or dynamic desirable, or trunk. Okay, now the options are described in the table. So access. Access means permanent access mode and negotiates to convert the neighboring link into an access link. That means if you are going to connect a computer or a workstation on the switch port, then it should be in access mode. Okay, now dynamic auto, this will becomes a trunk interface if the neighboring interface is set to trunk or desirable mode. Dynamic desirable, it actively seeks to become a trunk by negotiating with other auto or desirable interfaces. And trunk, it permanent trunking mode and negotiates to convert the neighboring link into a trunk link. Okay, so we use the switch port non-negotiate interface configuration command to stop DTP negotiation. Okay, so the table here illustrates the results of the DTP configuration options on opposite ends of the trunk link connected to a Catalyst 2960 switch ports. So best practice is to configure trunk links statically whenever possible. Okay, now for instance, if you set the other end, okay, so these are considering two switches. Okay, so for instance, I have here a network. Okay, so something like I have switch 1 here. Okay, and let's say this is S1, this is connected to another switch here. For instance, this is S2. Okay, now if we are talking about this link here, okay, so to be a trunk, okay, for instance, you've got switch 1 on this case. All right, so this is for switch 1, and on top here is the configuration for switch 2. Okay, if switch 1 is in dynamic auto, okay, and switch 2 is also on dynamic auto, that would give you an access mode. Okay, if switch 1 is dynamic auto and switch 2 is set to dynamic desirable, that would give you a trunk. Okay, so this link here will become a trunk. If switch 1 is configured to be dynamic auto and switch 2 is configured a trunk manually, it is a trunk. Okay, when you combined dynamic auto and access, that would give you an access. Okay, so this is the purpose of that table. For instance, another example. So switch 1 is configured dynamic desirable. That would give you only an access to the link if the other end, switch 2, is configured an access. The rest will be on trunk. All right. Now, if we configure switch 1 with a trunk, okay, and the other end of the switch, which is on switch 2, so that would give you limited connectivity if it is set to access. So if you configure the trunk, okay, and dynamic auto, dynamic desirable, and trunk, all of it will give you trunk. Okay, so last one, if switch 1 is configured on access, okay, so all possible combinations except trunk will give you an access mode. So this is the purpose of DTP, okay, or dynamic trunking protocol. But then again, let me remind everyone that DTP is a Cisco proprietary protocol and runs only on Cisco devices. Okay, so it is recommended that we turn this off if you are connecting to a non-Cisco device. Okay, now the default DTP mode is dependent on the Cisco iOS software version and on the platform. So to determine the current DTP mode, we issue the command show DTP, okay, on the platform, okay, or show DTP interface command as shown here. Okay, show DTP interface FA01. Yeah. Okay, now take note that general practice is to set the interface to trunk and non-negotiate when a trunk link is required. So on links where trunking is not intended, DTP should be turned off. Okay, so this is the end of our video lecture. I hope you see the video demo that comes with this video lecture. Have a great day. See you on the next video lecture.